Hello. Right, bear with me. This will take barely 5 minutes, I believe. Okay. Now, geotechnical design on power groups. Now, power groups and single power. So basically, power groups are just a combination of single powers, right? The bearing capacity of a power group in the cozy soil is normally less than the sum of the individual powers. Meaning that if one single power, say it can take 1 kilopascal, you put 10 times 1, by the way, you have 10 kPa, but no, it will be probably 9, 8, 7, or even 5. So why is that so? This is because there is such a thing called group efficiency. As we learn in this engine output efficiency, simply it means what you get over what you should be getting. Right, Q, that is the ultimate bearing capacity of the group, and the ultimate bearing capacity of the individual powers multiplied by how many you have, and normally it's less than 1. Alright, efficiency is less than 1, meaning not 100%. So in fact, when your power spacing is more than 7D, you can get it to 1. But more than 7D, D is the diameter of the power. That is a very, very big spacing. You might as well go on and use single power. Alright, so in such a situation, it is not quite possible or feasible. Essentially, your efficiency will decrease as the powers get closer in the group. So we shall see. In fact, it is being told here, just bear in mind this, when it goes up to 1.5D, at 1.5D, your efficiency is only 0.3. Let's look at the diagram here, or the chart here, to illustrate this. Okay, remember we said, if you are looking at the spacing of 1.5 times the diameter, your efficiency is actually just 0.3, 30% of what you are supposed to get. Alright, and when you increase the spacing, as you go down here, just look at the blue line, which is for a 9 by 9 power group. So 9 by 9 meaning 9 on the x-axis and another 9 on the y-axis, right? A square formation. So as you go up, when you have 2 times the power diameter, then you get about 0.55 efficiency. When you go up to about 2.2, about 2.2, 2.3, you get about 0.65. And from then on, you can see the slope of your plot is getting gentler now. The gradient is a lot gentler than here, meaning that from about 2.2, 2.3 onwards the spacing, no matter how far apart you put them now, it is not going to make a lot of difference now, because the highest it will go, in fact at 4.5 times the diameter, you will come up to about 0.8, that's about 80%. Alright, so that goes on to show. Now, why then do we still use power groups? Now, look at this diagram here. For individual power, this is the pressure bulb. Remember, we learned this in chapter 2, the pressure bulb that you get for individual power. But when you have power group, the bulb is actually a combined effect of all the powers in the group. Alright, so in this case, it could be 5 by 5, 5 by 4, it could be anything. So the bulb is bigger and deeper. Hence, the settlement that you can expect is a lot bigger. Alright, and number 2, we use power groups in order for it to reinforce the soil as well, apart from taking the soil, the load from the top to a greater depth. So imagine having one single stick being poked into the ground and a group of sticks being poked into the ground. Which one will be stronger in terms of strengthening the soil, right? Of course, a group, because it's reinforcing the soil. We are a group of them. Why? Because in between, right, in between the powers, the soil is being compressed, if you like, being pressed around by the 2 sticks. Right. So the more sticks you have, the soil that's being confined between the power groups are actually being stiffened and strengthened. And that is why, if you look at the literature, you see that the failure of a power group is rarely individual powers. It's always a block. The whole block of them feeling as if they are one single unit, one big power, if you like, alright, instead of individual powers. Okay, so that's all for chapter 3.1. We'll see you again soon. Right, bye-bye.